Okay, so moving on to challenge 28, let's take a look at this one. It says a gardener needs to buy some turf for a project they're working on. The garden is rectangular with a circular flower bed in the middle. Produce an algorithm that asks the user for the dimensions of the lawn and the radius of the circle in meters. Calculates and outputs the amount of turf needed. So sometimes it helps to try and visualize the actual question. So if we go into shapes and draw what the rectangular garden might look like. So something like this is our garden, and it says that there's a circular flower bed in the middle. So you will have some sort of circle shape cut out of the middle of the garden, like so. So when you visualize the garden like this, it makes it a little bit easier because we need to know 3 different things to be able to work out the area of the green area. In order to do that, we need to know the width, so we need to know how wide it is going across, and we need to know the length of the garden, and we also need to know the radius of the circle. So what we're going to do is put the program together with our 3 inputs first. So we're going to get the dimensions of the lawn, width and length, and the radius of the circle. So we're going to start by doing that. Now I've already typed these in just before. So we've got lawn width, lawn length, and circle radius. Now this time I've put them all in as floats as the data type. And that's because when we're talking about width and length, it's unlikely that it's going to be a perfect whole number. It's more than likely going to be half a meter or something like that. It's got enter the width of the garden. The question mentions meters, so we're going to put in meters at the end of each one, just to make sure that everyone puts the correct values in. And now once we've got those 3 values, we need to calculate the area of the circle and the area of the lawn. So we're going to do circle area, and we know that that is pi times radius squared. So we're going to do 3.14 multiplied by the radius squared. So we're going to do circle radius. Now to do to the power of, whether it's to 2, 3, 4, 5, doesn't really matter. You need to use double star. Double star is essentially making something to the power of. So we're going to do circle radius to the power of 2. Now again, as you know, we need to do that first. So we're going to put those in brackets to calculate the circle radius to the power of 2 first. And then we're going to multiply it by 3.14. So that's going to get us our circle area. Now, by the way, in the exam, if you just put in, instead of using 2 stars to the 2, you might need to put in something different. So I've just checked in the reference guide from OCR, and it says that we can do exponentiation, or put an exponent in, by using the upwards arrow like so. Now that is a possibility that you can do, but at the same time, as we've been told, if you program in Python or write your language in Python, you won't be marked down for it. But if you were wanting to do that, you could put that symbol in, and that is the same as to the power of. But for it to work in Python, I need to use 2 stars. So that's going to calculate our area of our circle, which is the blue bit in the middle. And what we need to do next is work out the area of the lawn, so the main area of the grass. So we're going to put lawn area equals, and that's going to be lawn width multiplied by lawn length. Okay, now as you know from maths, once you've worked out this large rectangle, we need to subtract the circle in the middle to get our overall area. So what we're going to do is call it turf needed, I suppose, is lawn area minus circle area. And now that we've worked out how much turf we need, we just need to output it to the screen. You will need this much turf in meters squared. Okay, so we're just going to run this program now just to make sure that it works. Enter the width of the garden. We'll keep it to nice, easy numbers. So we know that 10 times 5 is just going to be 50. And we're going to put the radius as 2.5. It says that we need 30.375 meters squared. So that is working, that is the program finished and completed. Again, this one is not massively difficult. Our only major change is that we've switched our data types to floats so that it can be a bit more accurate. We've also done 2 separate calculations and then used the results of those to do our final calculation. So that is essentially a maths GCSE question really put into an algorithm. Now the only way that we can make this a little bit more precise is we can actually import a library called maths or math, and then we can use math.py instead of 3.14. And now when you do it, you get a much more accurate reading, which is very, very precise. So that is how to use the math library. You can import math and we can use math.py instead of 3.14. So that is the end of challenge 28.